artificial intelligence will completely transform our world. But what is AI? Why will it affect you? And how can you and your business survive and thrive through the AI revolution? Welcome to AI and You. Here is your host, author, speaker, and futurist, Peter Scott.
Hello and welcome to episode 228. I'm talking with John Laird, Principal Cognitive Architect and Co-Director of the Center for Integrated Cognition, and he's explaining cognitive architectures to us. John is the John L. Tishman Emeritus Professor of Engineering at the University of Michigan, where he was a faculty member for 36 years. He's a Fellow of AAAI, ACM, AAAS, and the Cognitive Science Society. In 2018, he was co-winner of the Herbert A. Prize for Advances in Cognitive Systems. Last week, we talked about System 1 and System 2 thinking, decision loops, models of the mind, symbolic versus neural models, and how large language models do reasoning. In the conclusion, we're going to talk about relationships between cognitive architectures and artificial general intelligence, where explainability and transparency come in, Turing tests, where we could be in 10 years, how to recognize AGI, metacognition, and the SOAR architecture. As we get back into the interview with John Laird, I'm wondering whether building better models of cognition requires learning all the time, like people appear to do, instead of all in one go, like artificial neural networks. Here we go. Do we need models that have continuous backpropagation?
I think that you just went in a whole different direction.
Okay.
So I would claim that backpropagation is one kind of learning mechanism, but it's not clear that the brain actually uses backpropagation at all. There's a lot of neuroscience that suggests the kind of signal that has to be sent back by backpropagation is not found in any, or at least in the majority of neural structures. So there are people who look towards how to do the same kind of learning as backpropagation, but without that specific kind of algorithm. So I think if the neuroscience, don't want to be unfair, but the computer scientists and, control theory and other people before them discovered backpropagation, which has been hugely successful, but it doesn't mean that that corresponds to the way neurons learn. I mean, a good example is Hebbian learning, which seems to be an important kind of learning in the brain, and that does not require backpropagation. It does not require differentiable signals. So this is a case where I believe there's been a disconnect between a lot of what's been going on in AI and what we know about the neuroscience. I would be curious if you ever saw, when you were reading Grossberg's book, any mention of backpropagation. So
no, it was pretty much all, as I recall, about the biological structures. But you give me a lot to file under the heading of Today I Learned here. Let's talk about cognitive architectures that will support artificial general intelligence, which you have been working on for some time. What are the characteristics of a cognitive architecture that will support that?
Well, our view as being the most productive path to go down is to look at, first you have to define what artificial general intelligence is. And some people claim we've already achieved it or it's going to be achieved in 5 years. I think that we're very far away from it because I think of artificial general intelligence as having essentially most of the capabilities that humans have, not in terms of being as smart on chess or a math or whatever, but having the general capabilities of using the different sources of knowledge we have in order to do our learning and our reasoning. And I think we're very far away from that. So the fact that we have large language models that don't learn online or continuously, that shows to me that that might be an interesting technology for us to explore, but whether it's on the path to artificial general intelligence is an open question. So I think there are these capabilities like being able to do online learning that are very important. I also think being embodied in something that is sensing its environment and acting in the world is an important part of that. And that doesn't mean that we have to only do this within robots, but I think understanding how to do perception well and do things like imagery, I think is an important part of general intelligence. also having huge amounts of knowledge, which is what we've seen being able to be done with large language models, is something we want to have, and being able to accumulate that over time as the agent interacts with the world. So there's a lot of these types of constraints on what means to be artificially general intelligence. So it makes it a really hard problem. I do think that being inspired by what we see at an abstract level and how the brain works is a good path to follow. It might not be the only path. There might be AGI systems that come along that are different than what we see in the way humans are built. But I think that from a scientific and engineering perspective, it's a good way to do a bet. Now, you can see that I'm sort of hedging my bet, or I'm not completely going that way, because I'm not starting with neurons, and I'm not saying I'm going to build systems with neurons to start with, which is clearly how humans are built. I'm sort of starting at another level. And I must say it's a very selfish reason, because I want to be able to build systems today that have a lot of the capabilities that I think should be in AGI. And I found that, at least when I got started, doing that with neural systems was going to be difficult, if not frustrating. So that is part of why I've gone down the path I have. Maybe in 10 years, everything will be more based on, the level I'm working at will be, as I said earlier, will be implemented with neural structures, and we won't have the kind of level explicit that we do in our systems today.
So to eliminate this from a different angle here, the more symbolic angle, Doug Lennart built Psych and later on Nell.
No, he did not.
Oh, he didn't build Nell? Okay, but he built...
Tom Mitchell built Nell, never-ending learning.
Right. But Doug Lennart built Psych early on and was operating under perhaps the model that human beings seem to learn by having vast numbers of facts piled into their brains from an early age. And if we piled enough facts into a expert system, perhaps of some kind, of some strain, that it would do the same thing that human beings do and connect them all. That didn't work. What do you take away from that?
What do I take away from Psych?
Yeah.
So Psych did not look at how humans do reasoning or learning. Initially, it was all done by human ontologists writing lots and lots of statements, sort of like logical form, and building the system out mostly by hand. And there was always the promise that at some day you would get to the point where there was a critical mass, as you were saying, of knowledge, that then you could read books and things like that and incorporate them in, and that would then directly build new symbolic structures. And that sort of also, at a very abstract level, was part of the philosophy of the Nell system, which was a system that was sort of searching over the internet for knowledge and building it up that way. And what we found with large language models is that you still get extremely useful data without having to explicitly represent everything in sort of logical or semi-logical forms, and those symbolic forms. You still get a lot, but you still are missing things. So there's things that Psych can do that a large language model cannot do in terms of complex reasoning.
Right.
So I think what we don't understand is how to get the best of both.
Yeah. And with Psych, if it came up with an assertion, you could prove it. It was right there. There was no question that was reasoning.
Yes, exactly. And you were able to go back to where did that come from? And so that I have confidence in it. Whereas when a large language model produces something, there is nothing behind it. I mean, you can ask it, why did you produce it? But it will make something up. I mean, it will just create something. It's not exactly create what you want to hear, but it will just create something that is the most likely explanation. But there's no guarantee that it corresponds to reality. So there are these trade-offs between these different approaches. And so I do think there's different niches, and the niches might be very big, but there's different applications and uses for these different technologies. And I think that's one of the things we have to appreciate, that there's still things that systems like Psych do better than large language models. And for those applications, we shouldn't throw the technology out just yet. And we need to understand how a given problem, what the best approach is for that problem. So with deep learning that occurred before large language models, what we discovered is that in terms of perceptual processing, having deep neural networks was a very good way to do the kind of processing of speech signals or of vision that we didn't have before. So I think all of that is we're finding out what these technologies are best at.
I want to connect something you said with something that happened recently. And you said that you believe we're a long way from AGI at the moment. And a recent paper of a study said that we've passed the Turing test using GPT-4 Omni. And they did the classical test. I am wondering if in that environment where you're talking to an agent on the other end of a text chat, that there is some sort of shibboleth that you could apply that would tell you whether you're talking to a human or a machine, given the way you're thinking about general intelligence.
So I think you could do that, Peter. I think
good. Let's learn.
You have a set of questions you would ask in order to tell whether something was a large language model or a human. I haven't thought deeply about it, but one of the dangers is as soon as you publish, here is a way to tell them apart. These systems can memorize that and do it in the future. So for example, for many years, I've used an example to try to give people a feeling for what we mean by cognitive architecture. So let me just use that right now. So the idea is I ask you to imagine the word wow, and then flip it upside down. And then when was the last time you saw the spouse of that person? And so that uses, in cognitive architecture terms, a lot of different mechanisms. It uses imagery in order to imagine the word wow, but then you have the ability to flip it upside down where whoever asked you to flip a word upside down before, but you still knew how to do it. And then you were able to re-perceive it as mom and then access semantic memory to know what the spouse was. And so you know a spouse is your father, and you might not know who your father is, and your father might have passed away. But then you could still go and ask your episodic memory, when was the last time? And you might come back with nothing, or you might come back with last week. And so we don't see episodic memories in large language models or ChatGPT. So I don't know if those systems fake it. I'm not sure, having personal histories. But that's one thing they clearly don't have, is a personal history. So those are the kinds of things I would ask about, whether or not, if you push claim to shove and you said, well, if it didn't have that capability, could it still be general intelligence? I would say, well, I think you have to have episodic memory. I think you want to be able to reason about images in that way. The interesting thing about ChatGPT 3 or 4 and images is if you ask it what an upside down M is, sometimes it can tell you because it's in the things that it read about. It can't do the processing we can do in terms of, analogically flipping things upside down, but because it's seen text that describes that, it can capture that. So it's this interesting thing of having systems that just have read so much about this, and you have to find things outside of that to test them.
So if you ask that question and the answer comes back, as a large language model, I don't have parents, do you go, oh, going to need another test? Or has it gotten far enough?
Yeah, I don't know. Haven't thought down that path that much. This is not something I spend my time on. And it's interesting. So I will make the claim that the vast majority of people in AI do not think much about the Turing test. They just don't think about it. Whereas it becomes very popular as a way of deciding whether AIs are at a certain stage. There's just so many difficulties in administering it and what you actually learn from it, and so many ways to fake it, that it's just not that, we don't consider it that valuable.
Right. And we've talked on this show many times about that. And I think that's why it took so long for someone to actually get around to doing a proper Turing test with the models and why it received so little attention. But it is important for us to understand how to tell when something is exhibiting artificial general intelligence. Because after all, that is, for one thing, the business model of companies like DeepMind. And if they can't define it, they can't say when they've got it.
I think you're wrong. I don't think that's the business model of DeepMind.
It says on the homepage.
Okay. Well, I know people work at DeepMind, and although they sort of hold up AGI as a beacon for what they're headed towards, they along the way are developing lots of applications that do not require artificial intelligence. And so I think that they appreciate the fact that it's not all or none, that there's a lot of very productive things we can do without achieving artificial general intelligence. I would claim that's actually been a problem with the press and the field, is that they sort of set it up as saying, oh, well, until we reach artificial general intelligence, AI isn't doing great, it has failed. And it's like, no, AI has been so successful in many different areas that it's, changing people's lives, but it doesn't do AGI. And so we should also be continually asking, how can we solve problems without AGI? I don't think we need AGI to do many different things that will help people and make our lives better.
Thanks for illuminating that. And I haven't looked at DeepMind's homepage in a while, so it's possible that no longer appears there, but it certainly did in the beginning.
Well, it's funny because I sort of see myself working on AGI, but I don't know that I encourage everybody else to do it. I mean, I think there's a lot of very productive things that can be done with AI and very specific applications that don't require us to solve AGI.
Well, then, what would you like the fruits of your work to be 10 years from now?
Good question. My goal is to continually expand our understanding of what intelligence is, what general intelligence is, and how to incrementally get closer to AGI and what the computational underpinnings of it are, and also get better understanding of what human intelligence, human reasoning is. So if we make contributions to that, that would be great. I also have a very more selfish engineering standpoint. And so the little kid in me, which is, can we build AI systems that surprise us? Can we build AI systems that do things that start to approximate the intelligence of humans, that are able to learn over the course of their existence and get better? So that's some of the sort of more engineering AI-ish goals I have. But I don't expect that we'll achieve AGI in my lifetime. I would be shocked if we did. And so as I get older, that gets to be seeming more correct. Because although everybody sort of said, some people say AGI next year, then Gertzel says AGI in 2029. I don't think so. I think what you do is, as you do more capabilities into your systems and they do more, what we learn is what they're missing. And so we learn that they have things that don't do everything humans do, and we still have a long way to go. So I think that this is not going to be, we just take large language models, we double, triple, whatever the number of parameters, build things, and suddenly AGI is going to emerge. It's not going to happen with that technology. It might happen with some technology, but it's still a long way off.
I agree with you that pursuing the ever expanding large language model size is almost certainly a red herring, and people only doing it because it becomes a way of differentiating themselves through how much money they can throw at something, and whoever's got the most money can build the biggest model.
We'll see what the business model turns out there.
Yeah.
How successful that is in a few years.
Going back to something you said just there, what's something that an AI could do that would surprise you in a good way?
As soon as I said that, I was sort of wondering what that would be. I don't know. I'd have to think about that, but that would be a useful exercise. So that would be able to be a goal for us in our own.
Of course, it might then fall into that category of, if you define it, then a model can train itself on that and someone can build that in.
You're right. And that would have to be something outside of that type of capability. So the thing that we've been working on most recently is how to teach agents, AI systems, new tasks from scratch, incrementally with online learning. So you are interacting with it, you want it to do something new it never has done before, and you tell it, here's what I want you to do. And so, for example, we had a system that was like for patrolling through a building and doing a set of tasks as it's patrolling through a building. And you have to tell it what that task is and what it has to do in different rooms, that it should turn lights on when it goes into the room, turn it off. It impressed me that we were able to build a system that through only language interaction, you could teach it to do something completely new like that. And our extension that we've been working on most recently is it gets to be sort of tiresome to go through the details of how to teach a task like that, because often you have to use new words. And so now we hook it up to the GPT-4, and it goes out and tries to get information from GPT before it asks us questions about things it doesn't know. And then it's instead of asking a question from scratch, it will say, here's what I think you meant, or here's what I think that word means. And then the human will confirm that. And so that's been the direction we've been going to try to leverage the knowledge in these large language models, but also having it under control of the human. Because as we go forward, and it seems like none of the big systems out there are going to be specialized to you. And so the reason we want to look at how to train systems through language and through online learning is I want to have, if I ever have a robot in my house, I want to tell it how to do things in my house and how to do things the way I like them to be done. And that's going to be difficult if it can't learn.
Right. My Roomba still can't do the stairs. What would be a defining characteristic, or what would not be a defining characteristic of a cognitive architecture that you would say was capable of doing artificial general intelligence? If someone said, hey, we think we've done it, and you say, great, let me look under the hood. And for instance, if you see that it's still got training phases, do you go fail or what?
Well, I wouldn't say that training itself is a complete red flag, because you could argue that the first N years of life for us is training. And when do you say that a child when they're 1 day old is not generally intelligent, but a kid when they're 6 or 7 is pretty close to that. So we have that training aspect as being important. I would say if they have a module that's the planning module, and that was developed independent of everything else, and it sort of is the planning module. And that is something that can't be learned and gotten better. That's an issue. If it doesn't have the capability of doing explicit tasks in order to make itself better. So for example, one of the things we do, we call this level 2 learning. There's the learning that happens automatically through all of the, we say, architectural learning mechanisms. Like we get faster as we do a task more often. We learn things through episodic memory. But one of the things we do is we do strategies that take time in order for us to learn. So if you want to learn a foreign language, you might go and buy a deck of index cards, and you might write on one side the English word and on the other side the French word. And then you start training yourself with flashcards. And the way I see it, you have decided I want to learn something, but your learning mechanisms themselves are not getting exposed to the information they need to. So you're going to train yourself. You're going to create an environment in which your automatic learning mechanisms are going to do that. And so we have that capability to step outside ourselves and say, what can I do in order to make myself better? If you are a sports person, you practice over and over again, not because practice is necessarily fun, but because you know that in order to get better, you have to practice. So you have metacognitive knowledge about your own capabilities and what you have to learn. So I would be looking for something like that in a system that is not just doing tasks in the world that I tell it to do, but also on the side, when it's got free time, is asking itself, how can I do these things better? Or what can I do more? That also gets into a scary area, because you want to make sure its values are aligned with yours, and what it's going over to explore and do better are things you want it to do. So I think we don't necessarily want AGIs to be exactly like ourselves. We want to make sure that they are aligned with us and that they are helping us as opposed to just being there. So I talk about AGI, a lot of people talk about AGI, but I also think we need to always be asking ourselves, how do we make sure that what we're developing is complementing us and helping us?
Yes, I do that process that you're describing. Well, everyone does a lot of pushing like system 2 level thinking down into system 1 so that it can be fast enough. Like I'm learning pickleball, and it's not the same as tennis and table tennis, which I know. And my learning is all about pushing this down into a level where essentially my eyes are connected to my hand without having to go through my brain first. At least that's the way it feels. So you talked about metacognition. Does that sound like self-awareness to you?
Well, that's part of it, that you are able to make representations of yourself. For us, we would say in working memory, that you are able to reason over. And metacognition is a pretty interesting area that we don't have a good understanding of all of what's involved computationally with it. And there's a lot of different things that fit under metacognition. So there's the ability to monitor oneself, but there's also, I would claim, this ability to decide to do tasks that are not going to help you right now, but help you in the future. So another, I don't know if you want to call it metacognition, is you look out and you see that it looks like it's cloudy, and then you say, oh, it's going to be cloudy. I might get wet sometime in the future, and so I'll take an umbrella today. And it's not that I need an umbrella right now, so I'm not reacting to the current situation, but it's thinking about what situations I'm going to be in the future and asking, what should I do now to be prepared for those? Whether we call it metacognition or other types of processing, I don't know. But I think there's a lot of these kinds of things that we have to have better understanding of and ask, how do we organize our architecture so that they have these capabilities?
Wow. And
I don't see them. I don't think there's a plan for a umbrella when on a rainy day module. I mean, so the question is, how do the more general capabilities we have get marshaled for doing these more specific things? And that's just a real challenge. And so I see all these things and say, this is really hard. I don't think we're going to get that in 4 years.
Understood. As we start to proceed to a conclusion here, what haven't we touched on that you'd like to make sure listeners understand about your work?
Oh, I think we've covered a lot of ground, so that's fine. Yeah, we'll say that this is sufficient.
Well, thank you. And what should listeners know about where to find out more about what you've done, what you're going to be doing, how to follow your work?
Sure. So the system I've been working on for many years is called SOAR, and we continue to work on it. So it's SOAR. And if you just do a search on any search engine and say SOAR cognitive architecture, our website will come up, and that has a lot of pointers to publications in the past and also software you can download. It's not the easiest software to use, but there are a lot of people out around the world that are using SOAR for developing systems. We started a Center for Integrated Cognition, CIC. And if you search for that, you'll find us, and we have a website there that describes our mission and some of the projects we're working on. So I think that's the best way to learn more about the kind of work we do.
Is integrated cognition a label that I would find useful for differentiating or drawing a distinction that I might not have otherwise?
Well, if you go back 15 years, I would claim that a lot of AI was not integrated cognition. A lot of AI was planning people, vision people, language people, all these other people. And so for me, the question I continually ask is, how do all of those systems fit together? And how do they fit together? And so maybe this is, what do I wish I had said? One of the things we see people being able to do is if they're working on a language problem, they're trying to understand language, somebody uses a word, they can then use almost all their cognitive capabilities to get that. They can go ask a person, they can go read something. They're not limited to their language module that only does language. And so one of the cool things we do is have that ability to go and sort of recursively use all of our capabilities for any capability that we're trying to do. And now you have to have time, so it can't be something where you're driving and you have to make a decision in a short amount of time, because as we've talked about before, this is what Kahneman would probably talk System 2 or even beyond System 2 reasoning that requires people a lot of time to use. But that's a capability that we have, and I think it's really important that we do see in humans, we don't see in AI systems. And even today, most language models are language models by themselves. And so how do we get language models integrated in with other pieces and all these technologies together? So we actually held a symposium last fall, almost a year ago, on the integration of cognitive architectures and generative models. And through AAAI, the Association for the Advancement of Artificial Intelligence, they have proceedings of that on their website somewhere. So if you search for the Fall Symposium 2024 on integrating cognitive architecture and generative models, you'll find stuff on that. So I think that's another resource. But for me, integration has been something that is not necessary to make progress in individual areas of AI. But if we want to make progress in general intelligence, we got to ask, how do these pieces fit together?
Well, and that provokes something I wish I'd asked in turn, which is that we have made all this progress in language, perhaps because we're looking where the light is rather than where we lost our keys. It's easiest for us to do because we know how to represent strings of text in a computer. It's something we've done for a long time and we're very good at it. But things that humans do, like move their body, have proprioception, can smell and taste things and pick things up, do not have representations that we have encoded nearly as well, nor gathered that kind of data on. And yet that presumably plays a large part in our intelligence and ability to manipulate the world that perhaps unfairly, but the large language modelers would rather ignore.
They're not one thing. Large language models are not, they're not a cabal. There's a lot of different people doing different things with language models all over the world. There are people that are trying to gather data on putting people in exoskeletons and having people move around and gathering data on how they move and getting huge amounts of data and putting those through transformers. So we have language models and we have generative models and transformers. I do see a wide variety, but then those people are looking at how do we do manipulation independent of language. So I do think we will see progress in these other areas. Don't know about smell.
But you would want to see those things integrated, would you?
Yeah, so I'd like to see more. And we are seeing some integration. So people have looked at vision and language in limited situations so that you can give an image to a computer and it can describe it. But there's a lot of limits to what it can really do. So I think we're seeing pieces. You asked me, what do I hope in 10 years? So this is really being honest. I hope more of the AI world takes a look at cognitive architectures, not necessarily SOAR or a specific one, but they look at that as a integrative. I'm a broken record here, Peter. They look at that as a way to integrate these kinds of different aspects of what makes humans intelligent together. So that's what I'm hoping that happens in the next 5 or 10 years, is we get more people looking at the science and technology and theory of cognitive architecture for applications across AI.
Well, that's an excellent place to leave this. And so thank you, John Laird, for giving us such
great questions.
A fascinating take on this subject. It's really illuminated it from a whole new set of directions for me.
Good. Well, maybe we can do this again in a few years.
Look forward to it. Thank you. That's the end of the interview. I took a closer look at the DeepMind website and verified that they started mentioning artificial general intelligence in their description of their vision from sometime in 2019, which was obviously pretty bold at the time, but I was speaking too loosely to call it their business model, which it can't be yet. I think it's really interesting how we're starting to pick out the edges of this thing called AGI and how to recognize it, or even whether we're asking the right questions. In today's news, ripped from the headlines about AI, visitors to Bletchley Park, the historic location where British World War II codebreakers cracked the German Enigma code, will soon have the opportunity to converse with a hologram of Alan Turing, the father of artificial intelligence. The life-size AI Turing will have the capability to respond to inquiries about his life, his contributions, and his critical involvement in the advancement of computer science and the decryption of Enigma. AI Turing will be able to customize its answers for various audiences by using facial recognition cameras to gauge audience sizes and composition. It could give tailored responses to individuals, groups, or children. The project is a collaboration between the Bletchley Park Trust and 1956 Individuals, a UK-based company specializing in AI character development. Next week, my guest will be Professor Caroline Bassett, Director of Cambridge Digital Humanities in the UK, to give us some important insights into who we are when reflected in the AI mirror. That's next week on AI and You. Until then, remember, no matter how much computers learn how to do, it's how we come together as humans that matters.
That's all for this episode of AI and You. Please leave a rating and comment and share with your friends. Get the book Artificial Intelligence and You and see more videos and articles at aiandyou.net. That's aiandyou.net, where you can also send us your questions. Thank you for listening.